There we go. Hey there, welcome everybody. Welcome again to Astronomy Daily Live. So hope everybody's doing well. So grab your favorite consumable of choice, sit back in our sort of virtual porch here, and let's think and talk all things astronomy and space and science and all that kind of stuff for at least a little while. Now, it is clear here. It is clear. There's no wind. The humidity, the last time I checked, right, which was just a couple of minutes ago, was at 55%, which is just fine for any kind of observing. Just fine. So I haven't bothered to go and look at the satellite loop. There's a big bank of clouds, sort of wanting to move in. So I'm thinking that that's still going to happen soon. So, but we'll see. Hey there, Bobby. I am hearing an echo, and I'm seeing you on the panel. What's going on?
Hey, not much. My phone was being retarded. It wouldn't let me turn down the sound and stuff.
Those phones, they just do exactly what we tell them to do, and not what we want them to do. Yeah, it's typical, computer etiquette. Just just incredibly rude. Yeah, so very cool. I noticed you were over on P&K Science earlier, and then you were over on Elliott Astro Imaging a little while ago. I was there too, obviously.
I was lurking on P&K.
Yeah. Well, I noticed you popped in once or twice. So yeah, that's a great crowd over there, and once in a while, you get some folks in there, some interesting ideas and stuff, and that's okay. I like that. Nothing wrong with that. We really need to keep an open mind about things, and so I have absolutely no problem. As long as people aren't mean and rude and crude and everything else, it's like, come on in and lay it on, right? That is perfectly fine. Everything that we think is true today, right, was once a crazy idea. Don't discount those kinds of things. I certainly don't at all. That's a great crowd over there. And Chris, he's doing some great photography and processing and showing all the details there and stuff. So yeah, great stuff. Also a great crowd over there too. So very cool. Check them out for sure. And also on the panel is Tom. Hey there, Tom. How you doing?
Hey, Cosmic. Doing fine, thanks. Hope you are as well.
Things are good. Hey, I didn't see it live, but a little bit afterwards, I saw the SpaceX launch. Did you see that one?
Yeah, I caught it. One of the Twitch streamers was showing it on his stream, so I watched there and listened to his comments, and everything went pretty well. They landed the stage 1 back on a solid surface.
Solid surface, yeah.
Yeah, got all the satellites deployed at their correct altitudes and all that. So
very cool. Success. Yeah. So these were what satellites? What were those?
That was the Iridium.
Okay.
Iridium satellites.
And how many?
I think
they actually deploy
10.
Wow.
And I think they have another set, but they're not going to deploy them all at once. The rest of them are going to be deployed as secondary payloads on other missions.
So I see. Cool.
They still have some of the old ones. I think there's a half a dozen or so of the Flash, the ones with the flares that are still in service, but won't be for long.
Not for long. Yeah, those orbits. I think pretty much any low Earth orbiting satellite is going to, at least eventually decay. There's not a lot of air up there, but we're still talking only a couple hundred kilometers up, a few hundred kilometers up, and that's just enough air, to provide a little bit of drag, and over time, but that might be planned also. I think that's an extremely wise thing. If you're going to put something up there, plan for its demise, so it doesn't stay up there, right? We've got so much junk up there anyway. We don't need any more. So yeah, the old ones are slowly decaying orbits, and they're coming down. So yeah, that'll well, we won't see any more flares, but communications will be improved. So very, very cool.
Right.
Yeah. And yeah, that was a beautiful launch. It was out of Vandenberg, yeah.
Yeah. Yep. And I think that's why they landed on the ocean. I don't think there's a place they can bring them back from a Vandenberg launch like they do in Florida. They can bring it back to ground, but
Yeah. So when do you think those landings are going to get like, oh, this is kind of boring, it's another one. When do you think that's going to happen?
I don't know. I think it's going to be a few years yet, because even though there's more and more launches, there's still not the quantity that you see with the air flight, where it has become commonplace.
Right. Yeah. No, it is so, it's still so absolutely cool, to see that. Because it's still, sort of so sci-fi, yeah, I think that's going to take a while. I don't know about you, but seeing an airplane, taking off and landing, I mean, it's not something I'd want to do every day, but when I see that's still pretty cool too. Even those sort of mundane things like that, that happen all the time. It's sort of like I can't believe that something that big is doing that. So yeah.
Yeah, there is still some awe about those kind of things.
Mm-hmm. Absolutely. All right, I'm going to look at the chat here really quick, see what's going on over there. ERT Radio is over there. The Human is over there. Hey, nice to see you again. Welcome. Andy's over there. Cool. So hope everybody's doing well out there. Had a nice chat with ERT Radio this morning. I'm deeply honored. I thought that was absolutely great. Great fun. Like I told him, and like I've said here, I can talk astronomy and space and music and all kinds of things all day long. Now, just as a reminder, right? I am generally a very, very, very quiet guy. I mean, really quiet. I say more words in this hour here, for sure, than I say all day long, right? And so talking out loud is it's not. I mean, it's just that's not really me, right? So that's really, I think, the only not really authentic me is that. But I'm basically just saying out loud my thoughts, right? So you know, it's not as if I don't think all day. It's that I just don't talk all day, right? And I would much rather, you know, when I'm in a crowd, I really enjoy, you know, just listening, you know, because most of the time, you know, the conversations are extremely interesting, and you know, I just like listening. Of course, I'm thinking the whole time, and I think everybody does that, of course. So yeah, you know.
So, Rico, about so any indication what the next Falcon Heavy launch will be?
Tom, you may know more a little bit about that, but I'm thinking like March or June or something. Isn't that what they're saying?
Yeah, there's nothing in the immediate future. The only thing I even see on the list is completely TBD. There's no date about it at all, and that's
Hmm.
I think that's another satellite they're talking about. And they had, I think they even postponed the unmanned, uncrewed flight of the Dragon capsule till maybe next month.
Oh, okay. Yeah. Yeah. Well, you know, they want to get that right, right? You know, you know, those kind, you know, I mean, if there's some kind of you know, error or, you know, problem, you know, with the launch or flight or anything, that would be bad, right? Because that would probably, you know, set them back a little bit, because they'd have to go back and, you know, try to figure out why. And that's good, right? You know, they're going to learn things. But, you know, if they have a success, then, you know, they can feel pretty confident, right? You know, their confidence goes up a little bit, that sort of what they're doing is right. So you know, I mean, yes, it's really hard, you know, to wait, but, you know, imagine what the folks at SpaceX are feeling, right? I mean, they're in it, right? They're actually in it. We're just sort of observers, right? Um, and you know, we feel, you know, the tension of it's like, you know, when are you going to do it? When are you going to do it? When are you going to do it? I mean, I can't imagine, you know, what they're thinking at all. It's got to be just crazy intense. Yeah. So, but yeah, you know, I mean, all the talk is, you know, Falcon Heavy this year at least, right? You know, maybe
So, like, I mean,
before June.
Roberto saying so sometime in 2019. That's cool. Some things just can't be rushed.
Yeah, that's absolutely true. You know, you don't want to have any kind of accidents. I mean, you know, like I said, you know, you can definitely learn from those kinds of things, but you know, it's a setback, right? Because you're going to have to, you know, figure out what went wrong and fix it. And, you know, if you have a fleet of these things, you might have to fix everything, right? So yeah, you know, it's a setback. Those things are going to happen, right? You know, stats say that, you know, you're not 100% all the time. So you know, you're going to have accidents. It's just bound to happen. But, you know, hopefully they won't happen. Um, and when they do, hopefully, you know, it won't be a major setback. You know, the Soyuz guys, right? You know, they had um, uh, that problem, you know, with that launch a couple of months ago. And what, in 2 weeks, 3 weeks, they were launching again. So you know, it's like, okay, you know, we know what happened. Let's go. So yeah, but it'll be really great to see another Falcon Heavy launch and landing.
What was
And
that rocket that actually was splashed down missing that ship?
oh, that there, SpaceX is also trying to capture the fairings. You know, the thing at the top of the rocket. You know, that big thing at the top that protects the satellites. Right, I think right. I forget exactly when that happens. I think right after the second stage fires, they release the fairings. Is that about right?
I think they have the main engine cut off, and then the first stage gets released, and then I think the fairings go. No, you might be right. You might be right. It might be the main engine cut off, then they do the fairings.
Yeah.
And then they light the second
right.
stage.
Yeah. Anyway, the fairings, they come off. There's two sides, right? It's like a shell, protecting the satellite, because as it's going through all that air, right? You don't want to expose, the satellite to that. It'll be ripped apart. But as soon as the rocket gets into thinner air, those fairings are just extra weight, right? And they're heavy, right? I mean, these are massive, massive devices, right? And so, they want to get rid of that weight so, they don't have to push it, right? Because that takes,
Enrico Roberto, what do you think of the new SpaceX Starship test rocket?
I totally agree with Tom. It's shiny.
And does Earth Purdue deserves a wrench?
How do I get one of them cool wrenches? I don't know. I'm gonna have to discuss that with a higher power. Yeah. I think you've I like the concept of everybody being on the Blue Crew, because it sort of makes everybody equal. And I think I'm probably going to be moving that way as this crowd gets larger. Right now, I've got a small crowd, and really, for this channel right now, wrenches really aren't even necessary. I think I've done the wrenches for Bobby and Tom because there was some need for it. And yeah, I think when there's a need, I think that can probably happen. I don't and maybe I'm wrong about this, but I don't really see being a part of the Blue Crew as anything better than being here at all. So yeah, that. But if this channel grows and the need comes up, yeah, I might change that policy a little bit. But yeah, I sort of at this point, it's sort of a non-issue. So yeah. But yeah, that can change, when the channel grows. So yeah, I think is that shiny rocket? Is that called the Star Hopper or just the Hopper? What is that? What are they calling it?
I thought that was the Starship Elon Musk was.
Okay, cool. Yeah. I'm really anxious to see what they're going to do with that thing. They've got some rocket engines on the bottom, maybe 3 of them it looks like, and it's nice and shiny. I don't see any windows. I don't see anything else, and they put it together really fast. And
it reminds me of the early science fiction movie spaceships.
Yeah. I really hope that nobody's sort of being blinded by that sci-fi stuff, the 50s sci-fi stuff. That that was sort of the motivation for the shuttle, right? And the shuttle was a beautiful thing, right? Absolutely fantastic. But it was an engineering nightmare, right? you know, it's absolutely no good, right, to have your spacecraft on the side of a rocket. That's a recipe for disaster. And you know, the fact that they were so successful with that is, you know, is you know, saying a lot about, you know, the mechanical engineers, and you know, all the folks, you know, who took that sci-fi concept and, you know, made it into something real. But you know, even when I first saw that, when I was a kid, it's like, really, really, that. I mean, isn't that just going to fall off of there? You know, just break off. Now, I mean, that never happened, right? But you know, the idea is that you know, to engineer that kind of a concept, um, I still think that's just, I don't know. It just doesn't seem very logical to me. I
What
mean,
was the idea of sci-fi when it first came around?
what was the idea of sci-fi?
Yeah.
To, I guess, to you know, sort of think about what the future was going to be like, and you know, absolutely nothing wrong with that. You know, one of my favorite authors is Jules Verne, right? And he wrote some fantastic books back in, what, you know, the late 1800s or so. You know, not only about, you know, a trip to the moon, but you know, going under the ocean, going back in time. Although, you know, I always confuse Jules Verne and H.G. Wells, so maybe I'm mixing those two up. But you know, both of those authors, I think, were H.G. Wells and Jules Verne, were they contemporaries? Did they overlap a little bit? I don't remember. If anybody knows, but you know, those two authors were. I don't think that they were necessarily the first sci-fi writers, but you know, those are sort of the earliest ones.
If that's like not the earliest potential, then what is the earliest? Asking Enrico Roberto.
Yeah, I'm not sure. I sort of think. I mean, I guess it sort of depends on what you define as sci-fi, right? I mean, science fiction, you know, fictional science, and you know, science, sort of modern science as we know, started, you know, back in the Renaissance, you know, back in the, what, 1400s, 1500s or so. In fact, Kepler, was it Kepler? Yeah, he wrote a book called Somnium, which I think stands for the dream. And I actually have a copy of it, PDF file. But I've heard, and I really need to read this book. But you know, he couldn't write any scientific papers about, you know, his thoughts and theories and stuff. So he fictionalized this, and I think Somnium was a book about traveling to the moon, right? So Kepler was, he actually wrote a sci-fi book way back. You know, when was that? Kepler was a little bit after Galileo, right? So you know, maybe 1600
When
or so.
was Da Vinci? Like before Kepler or after Kepler?
That was before. I think Da Vinci was around the late 1400s, early 1500s. Is that right? I think so. Yeah. So yeah, you know, I think sci-fi goes back.
Roberto's, Da Vinci's early drawings could be regarded as sci-fi. What do you think?
Yeah, I think so. I think so. Like I said, I think, you know, probably probably, the first sci-fi appeared as soon as there was sci, right? As soon as there was science, there was probably science fiction, because, you come up with some kind of a concept and it's like, well, if that's true, then maybe it can be like this, use our imaginations and, we can go
It's kind of like
lots and lots of
before there
places.
was ever was science, there was usually like something called the Bible.
Well, I think before science, there was a lot of, science is sort of a methodology for, trying to figure things out. Now, is the process of science valid or correct? Maybe, maybe not. I mean, we've been pretty successful with, the process of science, and so we're pretty confident that it works relatively well, in that it seems to sort of provide us with the answers, right? I mean, a lot of science, what science does and why we use science, right, is actually to try to predict the future, and if one can know, what's going to happen later on, that's a very, very powerful thing, right?
So, Enrico Bebeto, skipping Earth's radio's question for now. Early Mayan myths about the stars could not really be considered as sci-fi, right? Or could they be considered as sci-fi?
I don't know. It's a good question. Again, I mean, it sort of comes down to, semantics and definitions too. What do you define as a myth, right? Some people's myths are other people's facts. So, yeah, that's a hard one. But, I think I know what you mean, Eureka. And yeah, I'm pretty sure that we humans have been, using our imaginations for a really, really long time, right? We sort of base the imaginations on what we know, and what we experience, and project outward, in time or space or anything like that. So I think that we humans have been doing some form of sci-fi for quite a while. I think it's just part of what we do. And back then, right, they didn't have TV and the internet and radio to distract them. So I don't think it's as if they had a lot of extra time, but their use of time was different. When the sun set, right, it got dark. It got really dark, super dark. And so, what can you do when it's pitch black outside? Well, it's hard to do any, work. So, you sit around and you wait, you go to sleep, and so yeah, I think, I think probably the origins of modern sci-fi probably started, around, the Renaissance or so, 1400s or so. But I think using our imaginations, to try to project things, I think that probably goes back thousands and thousands and thousands of years. Yeah, for sure. So yeah. All right. Well, cool. Hey, I love talking about this kind of stuff. This is nice. Very, very cool. So cheers. I've got the HOH in here, and look at that. It's already halfway gone. So cheers. Hmm.
Hope it's
All
not
right.
becoming a crisis.
What's that, Bobby?
Hope it's not becoming a crisis.
It's no. It's I'm gonna keep the crisis at bay. Right, at bay. Just small sips. Mm. All right. Well, cool. I let's see. I was actually looking over at the I always forget what that thing is called. Yeah, the research notes of the American Astronomical Society, and found a couple of interesting things over there. You know, the AAS just finished up their meeting. You know, they have two meetings a year, one in January and one in June, where you know the astronomers from all over the world actually come together and you know present talks and lectures and what are called posters. You know, they make these big here, I'm gonna go back to that. You know, they make these big posters that you know has all kinds of you know words and pictures on it and stuff, and you know the presenter or you know the researcher stands there. You know, it's in a big huge room, and they stand there, and others you know can come up to them and you know read their stuff and you know talk about you know the work they're doing and all that kind of that kind of stuff. Really fun you know to have that kind of you know back and forth and stuff. So oftentimes you know the people who you know are just bringing in posters you know don't give any kind of presentation or talk or anything like that. But yeah, you know, I think probably the American Astronomical Society meetings are probably the largest gatherings of astronomers in the world. The IAU, the International Astronomical Union, I think they have one meeting a year, if I remember right. And that's pretty big too. So those are sort of the two big ones. And so you know, there's always a you know just a barrage of news. You know, because you know, the astronomers, you know, they want to make their big announcements at you know the AAS meetings, which is exactly valid, right? You know, they want to make a big splash. And so, you know, all kinds of new news, you know, new discoveries and lots of things have come out. I I actually haven't been following it as closely as I usually do. So I haven't really heard anything really big. I don't know if anybody else, either on the panel or on the chat has. I'm trying to think if I've heard anything really exciting. You know, there's always you know great news, but you know there's a lot of it. So yeah, I can't say as I've really heard anything that really stands out. I guess I don't know if this was part of the AAS meeting, but TESS, the transiting exoplanets. Oh, I don't remember what that stands for. TESS, transiting exoplanets. Something spacecraft. I guess they recently discovered their third exoplanet. Is that right?
Yeah, I believe that's right. That was last week.
Okay, cool, cool. Did they make that announcement at the meeting, or was it just before? I guess maybe just before.
I think I saw it in an article before that meeting started, but they may have talked about it there. I don't know.
Yeah, I'm sure. I'm sure. Yeah, yeah. Because exoplanets are, you know, um, most people are extremely excited about all these, and rightly so, right? It's a
That answers your question about tests, but is it might call it a survey satellite?
I think that's right.
Transiting exoplanet survey satellite. Yeah.
Yes. Okay.
Good
Yeah.
job.
Yeah. These acronyms are are just insane. Yeah, trying to keep track of all those things, my puny little brain can't do it. Yeah, that's when you look it up and it's there. No problem at all. But yeah, Tess is going to be doing some great things. In fact, they're going to have another data release really soon. And all that data, all the pictures, all the photometric light curves, everything are going to be, uh, grabbable by, all of us. If you're into that kind of thing, you can go, grab all this data and process it, in your own way. The really cool thing, right, about survey telescopes is that while Tessa's sort of primary mission is to look for these transiting planets, these planets that are actually passing in front of these stars, and we see the light curve, the brightness of the star actually fade and then come back up. It's
Okay, all
extremely
the
subtle.
Wright brothers has any form of connection with Space Sprite or no?
Um, how is are you talking about the Wright brothers in terms of the airplane guys? Um, I don't know if there's any connection there at all, except for inspiration, right? It's like once. I mean, I sort of think that once we realize that we actually could have powered flight, then it's like, wow, I'll bet you we can do anything. Because up until then, it was sort of like, well, maybe not. But I would think that a lot of sort of the engineering details, some of the technical details, probably did sort of translate to space flight. Um, but it's the concept of standing on the shoulders of giants.
And who's the one that had
And
the helicopter? That was Earth's first question.
oh yeah, I'm not exactly sure. I'm not exactly sure who came up with that. That's another the answer these days is Google is your friend. So those answers to questions about facts like that are definitely out there. Yeah, I can't be sure. I know Da Vinci had some kind of a flying contraption that sort of kind of looked like a helicopter of sorts. It used like a corkscrew kind of a thing. Yeah, the helicopter is just a rotating wing, right? That's all it really is. You have to sort of understand the concept of how a wing works first. And the Wright brothers didn't come up with that. They just knew about it, and it's like, let's try to make this work, right? So yeah, helicopter. I guess probably. I mean, most definitely came after the airplane.
I bet the Wright brothers joked about how they could one day reach the moon with pedal power, says Enrico Roberto.
Yeah. But of course, the Wright brothers were all about powered flight, and I think, I mean, at the time that the Wright brothers did their powered flight, did we have things like gliders? I mean, I know that we had, Zeppelins and maybe not Zeppelins, but balloons and stuff. But I'm not sure if it was the Wright brothers that actually came up with the wing concept. Did we have gliders before unpowered flight? Before the Wright brothers? I'm not sure. There are so many things that I just absolutely don't know. And compared to what I do know, it's like this compared to that. All right. So yeah, I don't know. But yeah, the Wright brothers, they were I think that's sort of an example of just sort of sticking to it and being stubborn, and being absolutely brilliant too, right? Amazing engineering, right? Absolutely amazing engineering, and not knowing if it was going to work, right? But being confident that it's like, what, we're going to make this go.
Okay.
So, and that's what it takes.
So he thought that they were the ones who had that pedal power aircraft.
I don't know their entire story, right? I mean, I know that they were bicycle makers, at least at one point. But how exactly they got into powered flight, I don't know that story. I'm absolutely certain that books have been written about that, for sure. So these days, again, it's easy enough to find out. And if nothing else, there's that great thing that we were talking about this morning on Ron's show. This great institution called the library, and there's these things called books. Yeah. And so, yeah, most definitely.
Uncle Bill, there are a lot of testing with gliders. Pretty sure they did lots of scientific testing, experimentation, documentation with small wind tunnels also. Their prepared designs were top notch for decades.
Cool. So they were working with wind tunnels too. Wow. And that I did not know. Very, very cool. Yeah. It's, we think that, we evolve sort of gradually, and that's not my observation, right? It sort of seems as though, like with technology, right? There's some kind of aha moment that it's like, aha, and then we sort of level off and exploit that, and then all of a sudden it's like, aha, and we get a little better, right? And then levels off again, and then aha. So instead of sort of a gradual thing, where we're just gradually getting better and better and better, it seems to be these big jumps.
Yeah, so the documentation is a great part. They left a lot into posterity. And on radio, they always put the favorite books at the back.
Yeah. Well, you got to work a little bit, right? All right. Well, cool. So yeah. So getting back to astronomical things. The AAS meeting is now over. It usually lasts. I guess it started. Well, I think it officially started on Monday. They sort of have pre things Saturday and Sunday. People like to arrive early, and then the actual meeting occurs Monday through Thursday. I think the last day was Thursday, and on top of all this, right? They have all the astronomers there who are giving presentations, and usually how this goes is that they have several tracks, right? So several talks are happening at the same time. I don't know how many they might have had this time, but typically, there were like 2 or 3. So, as somebody who wants to see talks, right, and hear talks, you got to look at the program, right, and you have to decide, which ones are you going to miss, and which ones are you going to see, and you have to, sometimes make some pretty hard choices, because it's like, these 2 talks that I really want to see both of them, either because I just, really want to see them, or maybe, this person, is talking about, some aspect of my research that I want to know a little bit more about, and I want to talk to them afterwards about it. But there's this other talk that I really want to see that, is doing exactly the same thing. So, really, really hard. So there's those, right? Then there are, the posters, the big things, with all the diagrams and words on it and everything. And then there's all the what do you call them? The commercial part, right? All the gadgets and all the swag and all the what are those called? The not the sponsors, but the trying to think of the right word there. Anyway, the retailers, the people who are trying to sell you stuff, and that's a big, huge crowd too. So lots going on, at those kinds of meetings. Always very, very exciting. Never enough time to see all the things that you want to see. And of course, where most of the action is, isn't actually at the meeting, but it happens over dinner, or it happens, they might have had like day trips or something, and so lots and lots of great conversation and getting together. Those kinds of things happen, sort of, not quite at the meeting. So yeah, lots and lots of great things. And just recently, just starting in October, the AAS started a sort of a service, online service, to allow researchers to sort of post these short, quick papers about some kind of discovery, or some kind of research, or some kind of results, and they are making those papers, at least right now, free to view, and so those are called I never remember the name, the research notes of the American Astronomical Society. So if you go to here, I'll post this over in the chat here, so you can take a look.
You're thinking of Cliff Notes?
Well, I suppose you could call them that, yeah. but yeah, these are sort of, like short and sweet. I think they are limited to like 1,000 words and one picture, right? One plot or one diagram or one image, whatever. And just short and sweet, quick things, just to sort of keep the community updated on what's being worked on. So it's sort of another avenue, to sort of peer into the bleeding edge of all the research and stuff. So from time to time, I definitely like to go over there and take a look and see what's going on. So let's go over there together and take a look and see what they're up to. So this is sort of the most recent one, and as you can see, it's volume 3. So they had. We can actually go back here. Let's see. So they've got journal archive. Yes. See, so they've got a volume 1, a volume 2, and a volume 3. And I think volume 1, like I said, I think that started in October. Yeah. So they have October. And I guess volume 2, did they combine volume 2 into November and December? That's the only thing that seems logical. Oh, okay. Okay, so this is volume 2, number 1, 2, 3, and 4. So, is this, sorry, you're watching, oh, this is 2017. Oh, okay. All right. I am behind the times. So yeah, this actually started over a year ago. Right? Okay. All right. Wow. I don't know how I missed that. So yeah, I guess volume 1 only had one issue in it, or at least that's the only one that's available for free, as they say here. But it's sort of looking like they are going to continue to make these things available for free, hopefully indefinitely. But the fact that it says this, to me, sort of implies that maybe at some point it's not going to be free, which would that would be a real bummer, right? Because this is pretty good stuff. So yeah, these things are updated constantly. As you can see, the last time number 1 was updated was the 11th of January, which at least in this part of the world is today. So not too bad. I think they're aiming to have a 3-day turnaround. So somebody submits a paper, and these aren't really peer reviewed or anything else. I'm not exactly sure what the process is. I think it goes through some kind of an editorial process, but they're wanting to get to about a 3 or 4 day turnover, right? So you submit your paper, and in 3 or 4 days, of course, as long as it's accepted, it'll be published, right? And these are completely referenceable papers that haven't, like I said, haven't been refereed, but they've sort of been looked over, right? And what the qualifications there are, I'm not exactly sure. They're not incredibly clear about how they decide what papers get through and what papers don't. So it'd be kind of interesting, here's me. It'd be kind of interesting to see what papers are rejected, and how many there are, that are actually rejected. That'd be an interesting piece of information, I think, because something like this, I would almost imagine would get a lot of submissions, and so it's like, well, how do you decide what gets through and what doesn't? I don't know. That's a responsibility I would not want to have at all. And there's a little bit of controversy about this too. Are these papers sort of valid scientific papers? Should they be referenced? And then again, like I said, how do you decide what a valid scientific paper is? Right? Does it have to, say the right things, whatever that is? How far outside of sort of, conventional thinking is sort of allowed? I'm not quite sure if they're going to publish those kinds of things. That's probably some kind of an internal thing. Not exactly sure. But here's sort of the latest and greatest from them. And I actually noticed here that there is this paper here that says light curves for all stars observed in TESS full frame images, sector 1 and beyond. So TESS is observing the sky in these different sectors, and I think right now they're up to sector 5. And like I said, I think there's going to be a big data release soon for sectors 3 and 4 soon. So sector 1 and sector 2 are already, down, and you can grab all the images and grab all the light curves and everything. And I think for sector 3 and 4, that's coming out like really, really soon, like in the next couple of weeks or so. I think they like to download all that stuff, when TESS is close to the Earth. So the transmission speed, is nice and fast. They can blast it down really, really fast. And then, of course, there's a processing thing. They actually take the data and they run it through some kind of processing pipeline, as they call it, where they take the raw data and the calibration data, and they make the raw data scientifically valid, and then they look for things, right? They look for changing brightnesses of stars and whatever else they do. Anyway, so this one kind of intrigued me because it says all stars observed, and it's like, how are you going to talk about all the stars observed in TESS in 1,000 words or less? So that these kinds of titles just beg to be looked at. So let's do that. So here it is. So here's a little bit information about the authors, which is really, really cool. You can actually contact the authors, and most authors are thrilled that somebody noticed their work. So don't hesitate to get a hold of these folks. Don't be shy. Don't be anything at all. If you have a question or comment, because like I say, these people, they don't necessarily work in a vacuum, but they may not get a lot of feedback, right? Except from sort of just sort of local co-workers and stuff. So to hear that somebody from the outside actually read my paper, right? That's like very, very cool, right? So if you have any kind of questions or comments, go for it. Don't hesitate. If they didn't want to be contacted, they would not give them your give us their contact information. So so this is pretty good. It was received on January 4th and published on January 10th. So not too bad, right? That's 6 days. And that probably includes a weekend, right? January 4th. Yeah, that includes a weekend too. So so really great turnover time there. Of course, here's all the references and all that kind of stuff. And here's the actual paper. All right, so they're looking at the differences between two images, say. They take one image and they subtract it from another. And that, eliminates all the things that are exactly the same and highlights changed. And so, that's a great way, to look for things that are moving or things that are changing in brightness or, any other kind of transient kind of thing, which, would otherwise probably be pretty hard, to actually see. So that's a great technique, works really well. Yeah, and been used for a long, but let's see, intended to the direction of full frame images, performance with single full frame data, extracted light curve, all the stars input catalog. Oh well, that's that's typical. It's how my brain works anyway. So yeah, yeah. Who knows why? That's probably out of my hands. If it gets impossible, then well, I'll just end the stream. But yeah, let's keep going here because I'm curious. I'm kind of curious to see if there's a picture. I always look at the 3-year-old. Can't really understand any of the words, but you give me a picture. Yeah, I'm usually pretty good with that. And then I can worry about the words later. So let's see. Right. So we use the first image as a master frame. And images were not resampled. Okay, so yeah, I think these images are pretty well lined up. I guess there might be a little bit of jostling around, but yeah, that's not too bad. So they did photometry on all the stars. That's what the fluxes were extracted here. They draw a little circle around the stars, and then they count up the data values, which correspond to a brightness in the pixel, which correspond to a certain number of photons actually going on to the CCD. So they're just measuring brightnesses here. So pretty big aperture, right? 73.5 seconds of arc is pretty test. So 100 stars. Am I lagging big time?
Yeah.
All right. Well, let's go down. Here we go. Okay, so they're just looking at the precision of their measurements in parts per million. So yeah, that's pretty good. This right. The bright stars, your measurements are usually much more accurate, right? Because the signal to noise, the ratio between the signal that you're getting and sort of the noise floor is very, very high, right? And so with the bright star, your signal to noise is very high. So you can usually very, very accurately measure the brightness of stars, right? Like an eighth altitude star as compared to. So that's why you're seeing this slope. You're seeing a lot of scatter too. So they probably have a pretty good explanation for that. Interesting, this kind of stuff because that what I'm doing right now, and so I see these kinds of numbers, and brings a smile face because I'm seeing numbers with my system. So my system is at least comparable to tests, and cool. I like it. That that just means that what I'm doing is pretty much exactly the same thing that they're doing. It doesn't mean that theirs is better, mine is better. It just means that we're doing the same thing. And for me, I'm just one guy, right? So I mean, I can be doing this totally wrong. So it's nice to see a large group of people working this data and getting the same kind of results. Multiple minds are working on this at the same time, and so it's really, really nice to see that the kinds of numbers that I'm getting are pretty close to what they're getting too. This kind of spread. Yeah, very, very cool. So yeah, but they've done this apparently for lots and lots and lots of stars. Did they actually say how many? Let's see if they give a star count. I'm not seeing a star count. That's kind of weird because we're talking about all stars observed, but they don't tell us there were. Fair. I'm just trying to see if there's any numbers here. This is, this is sort of the process that you have to go through, right? It's like, here, but yeah, I'm not seeing any. This is sort of a histogram showing, star counts over here. So I mean, in order to get the total number of stars, you'd have to add up all of these, and I mean, I'm not able to get that kind of information from this plot. Yeah. Okay, here we go. Oh, maybe we just didn't look far enough. So light curves, clean light curves, difference images, plotted light curves, data access and future reduction. So so they actually do have access to the data. Let's just go over and take a quick look here. But yeah, I'm not. They're not talking about how many stars they actually have in here. Which, okay. There are ways to find that out. A little while to download. I'm sort of wondering if my poor little machine is being brought to its knees here. Test full frame image portal. So here's a number. It says 106,399 points. So don't know if that's that's like an actual count or not. Kind of hard to tell. Maybe this thing, it looks like maybe it's still thinking. Not exactly sure what it's doing there. Guess we, oh, okay. Well, there's something. Yeah, I guess that's it. So 106,000 points translates to identified stars. So yeah, there's a couple stars there. So this is the right dimension here. I divided by 15, I assume, because TESS probably reports right ascension in terms of degrees, and every hour of right ascension is 15. So they've just sort of back into hours, right? So this is an actual section of the sky. I guess they were saying that this is section 1. I can't confirm that. Oh, okay, here we go. Yeah. So the file gigabytes in size, which yeah, that's these days that's actually not too big anymore. But yeah, so here we go. Like hers of 106,399 stars. Simulated images for you. I don't know what that means. Oh, here we go. Sector 1. Can we try this? Do we dare? Because okay, so that might have been just a simulated thing. So this download is greater than 300 gigabytes. There we go. All right, there's a nice number. So 1.2 million. Now, that's a number I can deal with. Sort of looks like they changed their units here a little bit too. EC long, EC lat, maybe ecliptic longitude, ecliptic latitude. Ooh, I don't know. I'm not exactly sure how to read that. Not giving a lot of info here. Let's see if there's something over here. See, the data has been reduced, the pipeline there. Please read the release notes, which can be found here. Raw light curves, data portal. Yeah, okay, I'm not quite sure what these units are. Obviously going from 0 to 360 and from 0 to -90. So that makes sense, right? I mean, that sort of implies, that this is some kind of position in the sky. And it looks like this probably because of the coordinates, they use. It sort of looks funny that way. So, well, cool. Looks like there's a lot of interesting things to look at here. I'm definitely not going to get into that much. Oh, sorry about that. Go away. It's kind of neat. They plot the magnitudes over here too. You can sort of see that looks like the majority of them are sort of this orangish color, which 16th, 17th magnitude. That makes sense. So cool, nice, and all this data is very much available. For sure. That's a lot. That's a lot for sure. But yeah, it's nice. It's nice, that they make this kind of stuff grabbable by anybody who wants to. And cool. All right. Well, nice. That's that's a lot of work, right? They processed 1.2 million light curves. That's whew, that's a major amount of work. But that's why we have computers to do all of this, right? I mean, it's not as if there are actually people doing this. We just sort of look at the results, check the results a little bit, and write papers about it. So very cool, very cool. It's Tess is absolutely fantastic, and Tess is just I mean, it's going to do amazing things, right? I mean, it's going to be up there for I think the primary mission just started, right? I think it's going to be going on. The primary one is going to be going on for at least a couple more years, and then most likely it'll be extended, right? Because we're going to find things.
You don't have any ideas for an earlier show for those in Europe?
An earlier show? Do you mean, this live stream earlier?
Yeah.
Is that what you mean? I've thought about doing a live stream at 14 hours UTC, exactly 12 hours apart. I've thought about that, and that would definitely satisfy you folks in Europe and Africa, and those areas. Yeah, I totally understand. I totally get that. This time here, starting at 2 hours UTC is pretty convenient for us, in sort of North and South America and like Australia, right? And sort of, East Asia.
Okay, if there's a possibility that you might be, if you're going to be running out of time, there's a possibility you ask Earth Radios tomorrow, or what?
Huh? I'm not quite sure what you're asking me, Bobby.
I'll check the chat.
In astronomy math, how do you calculate the appearance or motion of planets and comets? In a nutshell, what you have to do is you have to make observations, right? You have to note where these objects are in the sky, and then using that information, you have to calculate an orbit, right, for comets and asteroids and planets that are going around the sun. It's just an orbit around the sun. And, it's going to be some kind of an ellipse. That's sort of assumed. That's not always the case. But, in the case of, things that are actually going around the sun, it's some kind of an ellipse, right? So what you do is you make these observations over as long of a period as you possibly can of time. And those motions that you see are going to follow a particular path, right? I mean, a planet, right, is not going to be here and then here and then here and then here and then here, right? I mean, a planet is going to sort of move in some kind of a path, right? And if you sort of assume that it's an some kind of an ellipse that has one of the foci as the sun, then you can take a model, right, and create an ellipse, and stretch and move that ellipse around until it fits the observations, right? Once you have that, then you have a predicted orbit for this object. And then what you can do is you can run that planet either backward in time or forward in time, and see where it's going to be, right? And that's sort of in a nutshell how that's done. It's based on mathematical models, usually very complicated, right? I mean, those paths are sort of, but you have to take into account all kinds of other stuff too. I mean, it's just not the gravity of the sun, right? If this object, passes by a planet or, some kind of other asteroid or something, the path is going to slightly change over time. So there's all kinds of subtleties, right? But, Halley, right? He's famous for being able to predict when a comet, was going to come back, and he used the mathematical tools at the time, which are still valid today, and he made this crazy prediction. Remember that comet saw back when? Well, you know what? If this comet is going around the sun in this kind of a path, then we should see it in this location at this time. And so they waited, right? They waited and they waited and they waited. And it's like, okay, 2 more days, we should see it, right? 1 more day. And I'm not exactly sure how precise his prediction was, but his prediction was good enough that, lo and behold, when he said that we'd see that comet again, we actually did. And he got the gold star, right? I mean, he got that comet named after him, and to this day, right? It's Comet Halley, and well deserved. That's what I'm saying. That's one of the interesting things about science, right? Is that it allows us to predict the future. And if you can predict the future, why, that's pretty powerful, right? I mean, that's like Back to the Future, getting the sports almanac, right? And knowing, what football teams are going to win, 20 years from now, right? That's what we're doing here, right? It's exactly the same thing. And when that event actually occurs, we throw our hands up in the air, woohoo, right? That's really, really awesome. And that's one of the ways that science, can be used. Lots of other things too. Science is a tool, right? It's like a screwdriver or a hammer, right? And, it can perform, certain functions really, really well. And one of the things, that science can do is help us make predictions about things, which, like I said, is very powerful, right? So yeah, very, very cool. And orbital mechanics, celestial mechanics, yeah, that's pretty much exactly the same thing. I've got a great book on that.
Okay, Cosmic.
Yes, sir.
I actually am out of time, so I'm going to be decoding the shortwave radiogram. So
all right, excellent. Well, have a good time. Good luck with that.
Yeah,
good luck. I want a full report. Anyway, here's a great book. It's a little dusty. Sorry about that, but this is a really, really awesome book. Lots of details. I mean, this is sort of the fine print, right? Here's this one page, right? I mean, now, you definitely have to be a math nerd, to get into this kind of stuff. But, if you want to work these kinds of things out, that kind of information, to do that is definitely available. And yeah, like I said, it's sort of a simplification, to say, that these paths are, these smooth curves. They're not, right? They're wiggly and wobbly, and they change, and they precess, and all kinds of stuff, right? And this kind of book will definitely provide you with all the details, right? And this kind of stuff just for the most part, zooms way over my head. But if I were wanting to do anything like that, this is at least one of the books I would grab for sure. All right, well, cool. I think I'm going to follow Bobby and get off of this live stream. I think we've just had enough. So, all right, time to get out of here. So thanks everybody for coming in. It's really great, to have you all here. And I'm here every single day, pretty much every single day. It does sort of look like the live stream for the 16th of January is going to be canceled. I'm going on a road trip with the boss. I'm going to go grab a piece of lab equipment that we don't want it mailed. It's sort of a sensitive piece of equipment that we don't necessarily want to be jostled around the back of a UPS truck. So it's a pretty short drive. It's like a 6.5-hour drive there. So we're going to do it all in one day. We'll go up there, grab the thing, bring it back. That'll be fun. Once in a while, it's nice to get out. So that'll be nice. So yeah, I would say right now there's about a 90% chance that the live stream for the 16th is going to be canceled, but I will definitely keep you informed. So yeah, I think I'm going to get out of here for now. So thanks everybody for coming in. Have a great evening, a great day. Make sure to subscribe if you haven't. Spread the word about this, right? It's so much fun, to share this passion. And I've had this my entire life, and so I love to think about it. I love to talk about it. Definitely like to share it. Definitely. And this live stream is for all levels, right? So whether you're completely new, you are extremely welcome here. If you've been in astronomy for a while, you're very welcome here. And if you're a pro, come on in. This is a really, well, I'm hoping at least, this is a nice place, to talk about, the work you're doing, or, talk about work you've done. If you want to, have some kind of Q&A, we can do anything here, right? This is my porch. So and that means, we can do anything here. So, all right, well, for now, I'm going to get out of here. So take care, everybody. Peace, cheers, and all that. I will see you later.